QuickSort algorithm. It is also called partition exchange sort. It's an application of stack. It's an example for divide and conquer type of algorithm. Now let's see how the QuickSort is implemented using a given set of values. Now consider the given set of values. We'll start with choosing a pivot element. The first step in QuickSort is we have to choose an element from the given set as the pivot element or the key element. We can choose any element from the given set, but I am going to choose the first element. Here I am going to choose the first element as a pivot element. So I am assigning the pivot element as the first element of the array. Now the next step is to scan the rest of the elements in the array. So after choosing the pivot element, then we have to scan the array from left to right for a number which is greater than the pivot element. So if we scan the array from left to right for an element which is greater than the pivot element. So scanning from left to right, we can see that 55 is the first element greater than the key element. So I will stop here. The scanning will stop here. Suppose I is a variable used to scan from left to right, then I will stop at 55, right? At the position where 55 is stored. So I stands here. Now you have to do scanning from right to left also. So scanning from right to left, we are actually scanning for an element which is less than the key element. So in the first case, that is while scanning from left to right, we were scanning for an element which is greater than the key element, and scanning from right to left, we will be looking for an element which is less than the pivot element. So while doing that, we will stop at 22. So if j is a variable used to scan from right to left, then j will stop at the position where 22 is stored. Okay, now we have two numbers, one at I and one at j. The next step is to interchange these two numbers. So we will interchange a of I and a of j. After interchanging, we get the array like this. Okay, we have interchanged 55 and 22, right? If 22 has come here and 55 has gone here, right? Now we have to continue the scanning with the rest of the elements which we haven't scanned yet. Okay, so I travels to the next element. Now look at the next element, it is 77. From left to right, we are scanning for an element which is greater than key or the pivot. So 77 is greater than 44, so I stops at 77. Now right to left, we are looking for an element which is less than the key element or the pivot element. So j will stop at 40. Now again we have I and j. I and j stands for two numbers. We have to interchange these two. So after interchanging these two numbers, we get 40 here and 72 goes there, right? Again we have number in between these ij. So we have to continue the scanning. So left to right, we scan for a number which is greater than the pivot element. So I will move from here to 90. So I will stop here, and from right to left, we were scanning for an element which is less than the pivot element. So j will move from here to 40. Right. Now look at the positions of I and j. They have crossed out, right? They have crossed the limits. Once I and j has crossed the limit, we can say that I and j crosses the limits when I is greater than j. Since I was moving from left to right and j was moving from right to left, when I becomes greater than j, it means they have crossed the limits. We have to stop scanning from both the sides. Okay, so since I has crossed j, and so we stop scanning from left to right and right to left. Now where j stands, that is the position of the pivot element in the sorted list. So that means we were doing these scannings and all to find the location of the pivot element in the original or the final sorted list. Okay, so after doing these steps, the position of J gives us the position of the pivot element in the final sorted array. So J gives us a position of the pivot element. Now we have to interchange the element at J and the pivot element. Okay, so by interchanging these two values, we get 40 comes in the beginning and 44 comes at the location of J. Now look at the numbers. Now 44 was the pivot element. Pivot element has its location in the original sorted array. In the original sorted array, 44 will be at this position. Now look at the numbers. We have two sublists, one in the front of 44 and one at next to the 44, that is next to the pivot element. In the first sublist, look at the numbers. You can see that all the numbers in the first sublist are less than 44, and in the second sublist all the numbers are greater than 44. That means 44 is at the right position in the sorted list. So this is how the pivot gets its correct position in the list. Okay, so this is the divide and conquer concept. You first choose a pivot element, then we found the position of the pivot element in the sorted list, and using this pivot element, this array is divided into two halves, and that's how we got the first sublist and the second sublist. Now these steps what we have done here will be done separately for each sublist. Okay, and likewise we can sort all the elements of the array. For example, if we take the first sublist, again the first element will be considered as a pivot element. Then we'll scan left to right and right to left and do all these steps and find the position for 40, and based on that 40 we'll get another sublist, and that will also do these steps, and all the pivot elements will be getting its correct position in the sorted list. This is how QuickSort works. Now let's look at the QuickSort procedure. For that, we'll consider an array A with lower bound LB and upper bound UB. Now the first step is check whether LB is less than UB. This condition means that if there are elements in the array, then only we need to sort them, right? So if LB is less than UB, that means there are more than one element in the array and we need to sort it using QuickSort. So by checking the condition, if LB is less than UB, then we'll first do partition. We first call the procedure partition. Here the procedure partition actually finds the location of the pivot element. So in QuickSort we have to first select the pivot element, then find the position of the pivot element. Only then we can divide the array into two halves, two sublists, right? So that is done within the procedure partition. So after the procedure partition completes, we get the location of the pivot element, and using that location we will divide the array into two sublists, one just before from LB till LOC minus 1, and the second sublist will be from LOC plus 1 to UB. Now consider the array. If LOC is a location of the pivot which we got, then the first sublist will be from LB till LOC minus 1, and the second sublist will be from LOC plus 1 till UB. Okay. This is what is done through these two recursive calls. The first sublist LB till LOC minus 1 will be sorted by this call, and the second sublist LOC plus 1 till UB will be sorted using QuickSort by the second QuickSort call. So that's why we have used a recursion here, because we have to partition we consider the first sublist as a separate array and perform all the steps that we have done in partition, and again partition it into two sublists and repeat the same process is done again and again. Okay, now let's see what happens in partition. In the partition procedure, we have to assign the variables I, j and pivot, where I is a variable used to scan from left to right and j is a variable used to scan from right to left of the array. Now pivot is a variable pivot is the variable which holds the pivot value or the element for which we are going to find the location. First we initialize all these variables and then start scanning the array. Now the left to right scanning is done using this repeat until statement. We scan left to right using the variable I for a number which is greater than the pivot element. So that will be done using this repeat until statement, and the scanning from right to left for a number less than pivot will be done using this repeat until statement. And these two steps are to be done until I is greater than j. That is, when I and j cross out, that is they cross each other, we have to stop the scanning. So that is enclosed within the while loop where the condition is I less than j. Now if when we scan from left to right and right to left, when I and j is at two numbers which satisfies these two conditions, we have to swap those numbers. That is written here. Okay, now after scanning or after I and j cross outs, it means that we have got the location of pivot and the pivot will be at location j. So the j is to be assigned to LOC, where LOC holds the location of the pivot element. Once j is assigned to LOC, we can swap the pivot element and the element at location LOC. That is what this swapping means. Now after that, this partition will return the location of LOC to the QuickSort procedure, where using that LOC it will be partitioned into two sublists, and the same steps will be performed using these two recursive calls. So this is the procedure for QuickSort, recursive procedure for QuickSort.